Hi, today we're going to talk about the different types of matter. And first of all, I just want to explain that matter simply means it's just stuff. Matter is anything that contains atoms. So we can have many different types of matter. In fact, we have a hierarchy of matter. And I'm just going to classify everything of matter. We have two major types of matter. We can have things that are pure substances. So something that is pure and they're considered a substance. And then we have things that are considered mixtures. And a mixture just simply means two or more different things. Now, I know what we've learned in classes, we've learned that compounds are two or more different things combined chemically, but compound is actually not a mixture. So when we have our pure substances, we can have two types of pure substances. We could have an element and we could have a compound. Now when we have different types of mixtures, this is where it gets a little bit confusing, and I'm going to address this later on. We're going to be spending a lot more time with this. Is we have a homogeneous mixture, and then we have a heterogeneous mixture. So, let's make this. We have element, compound, homogeneous, and heterogeneous. This should go in your notes. You can make yours a little bit neater than mine. I'm going to show you some particle diagrams, but I'm going to use particle diagrams for these four types of matter. These are categories. We have pure substances, we have mixtures. In our particle diagrams, I'm going to use two different colors. So I'm going to draw four different boxes. And I'm going to use red dot and blue dot, and this represents atoms of different elements. Now, when we have I'm also going to do I'll do a couple of examples of each just to show you. Now, if I have an element is simply one specific type of thing. Now this right here this is a diatomic element. This could be one of the Hofbrinkels. And it is an element, it's a pure substance because there's nothing else in it. It's only the blue dots. And it is an element because there's only one type of atom present. This happens to be diatomic. Now a compound is slightly different. A compound, like if you recall, is two or more elements that are chemically combined. This is a pure substance because it's only the red-black. This is red-black, 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 red-black. Now if I had something like this would not be a compound, but I'm going to address that in a bit. Okay? Also, it doesn't matter if it's, and I know I said red-black, but I meant red-blue. If it were blue-red instead of red-blue, blue-red is the same thing because all you have to do is just turn it around 180 degrees, it's the same thing. Now these are pure because there's only blue here, there's only red-blue here. Now when we get into our mixtures are a little bit more complicated. We have a homogeneous mixture and a heterogeneous mixture. A homogeneous mixture means that everything is evenly distributed. Homo means same. A homogeneous mixture means it is the same distribution throughout. An example of a homogeneous mixture is any type of solution. Salt water. Air is a homogeneous mixture. anything that is in a solution. An aqueous solution is a homogeneous mixture. So I will show you a homogeneous mixture. We have one element, which again, this is a Hofbrinkel because it is diatomic. This is a homogeneous mixture because it is evenly distributed throughout. If you notice, it looks pretty even, the reds and the blues. Homogeneous. Now a heterogeneous mixture. And an example of a heterogeneous mixture is sand and water. Sand and water is not evenly distributed when you mix them up. The sand settles to the bottom and the water is distributed throughout. So an example of a heterogeneous mixture, I'm going to make it a little bit more complicated. If you look right here, it looks like these two are pretty much the same. In fact, this looks like it could be a compound. I have a red-blue here, a red-blue here, red-blue, 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 but then I have a blue-red-blue. So because of this one, and because it's not evenly distributed throughout the entire box, it's considered heterogeneous. Okay? An example of an element, anything on the periodic table, and the Hofbrinkels. An example of a compound, it has to be a pure compound. Sodium chloride, solid, is a compound that is a pure substance. An example of a homogeneous mixture could be salt water, or NaClAQ. In other words, an aqueous solution of sodium chloride is considered homogeneous. And finally, heterogeneous could be anything. Peas and carrots. It could be things that do not dissolve in each other. It can be oil and water, oil and vinegar. Anything where the two substances are not evenly mixed. Okay? You're going to look over here, practice problem. Peace.